Hello and welcome to Science, Mr. Robertson, back up the way into year 8 right now. And what's going to happen here is we're going to do a little video about a topic, and hopefully you can learn a little bit before you come to the lesson, so the lesson's even easier to understand. The topic I'm going to talk about today is something called enzymes, Enzyme på svenska. And basically, enzymes are our body's little warriors. They're the things that actually make our body work. Because every day in our body, there's different things going on. Food comes in, gets broken down into smaller pieces, goes to our muscles, use it for energy. We have to build up our cells again. We have to build more muscles. We have to build red blood cells, white blood cells. We have to poo. We have to make snot in here. Lots of things. Basically, our body is constantly doing chemical reactions. And when our body does that, it wants to do them as fast as it possibly can. We want to increase the rate, increase the speed of that reaction. The faster the reaction goes, I get what I want faster. I could, and I am going to actually, I could draw a graph here. And I could have the rate of reaction. And let's say we have temperature on the bottom. Now, your body temperature is a very healthy 37 degrees Celsius or thereabouts. That's what a normal body temperature should be. So let's put 37. Usually at 37. Now, think about cooking food at home. Water that's 37 degrees doesn't do very much. It would be quite slow. Your food wouldn't really get hot and cook in any way. What I can do to make the reaction go faster is I can make the temperature go higher. The particles run around more, bash each other around, hit each other more. They have more energy. You will get a faster reaction. That's good. So why don't we make our bodies even hotter? Well, if we did, we get up here, then remember most of our body's water. So if we get over 100 degrees Celsius, all our body is going to start cooking and evaporating. Not so good. Not so good. Instead, we can use enzymes. Because if I have a graph here like this, if I actually add enzymes in, and enzymes that are correct for my reaction, what I can actually get is a graph like this. Those enzymes make the reaction happen faster and easier. However, what happens is if you get a bit more than 37 or a bit more than 40, the reactions almost stop. The enzyme is no good anymore. That's because enzymes are made from protein. And when you get protein that hot, the protein basically changes its shape. And by changing its shape, it doesn't really work. For enzymes, I kind of imagine a key going into a lock. I have a key going into a lock. Only the right enzyme will open the key for the reaction. So, let's say I have an enzyme that is this shape here. And to get the reaction to happen, the right chemical has to come and fit in there. And then it could put it together, or it could break it apart, or whatever that enzyme's job is. If it's the wrong shape, if I try and put this into this here, they don't go together. It won't work. That enzyme does not help the reaction. But every enzyme that does can make that reaction faster. It just makes it easier for that reaction to take place. So we get more things when we want, as fast as possible. I'll talk about this for a second, this specialism, because there are different enzymes that do different jobs. Lots of the ones we're doing, we talk about food a lot in science at the moment. So, for example, a famous enzyme we have is amylase. Now, what amylase does, which is, I think, genius, is amylase takes the starch molecules, and it'll take the starch and it will break it down. Remember, starch is a polysaccharide, really long, and then it will do it into short carbohydrates. So that one starch molecule will break down into lots of small, different ones. Such an improvement, such help. What a great material. Without amylase, it's got to be starched for much longer. It'll take more time to absorb. And what's really clever is that our bodies actually make amylase in here. So we already start breaking down the starch into sweet sugars here, even before it goes down the rest of my body. And this is great because we can start to use different enzymes to break down or put together all kinds of different things. We can also use them to control how our body works. So when we eat, if I eat some food, I'm going to make the enzymes in my body to break the food down. And then, of course, the food gets broken down faster. But if my body doesn't want to do it so fast, I might break less of them in. I might not want to absorb so much sugar, for example, if I've just eaten a lot of sugar and I've not burnt it off yet. So I have that control that the enzymes can do inside the body. And of course, we can use them outside the body. We can do so many different things. For example, we can wash clothes. I could wash my clothes at a low temperature, but it doesn't work. My clothes are still dirty. I could wash them at a high temperature and, hey, that's good. My clothes will be clean. But I could save energy, use a lower energy temperature water, and add some enzymes to break down all my dirty clothes and all the bits of mud and food and whatever's on them. That would save me energy. So it makes my life easier. Wash clothes. You could also use them. A famous one for enzyme use is usually the production of beer and spirits and lots of food products like that, because you actually need enzymes to help start lots of the reactions to actually get the chemicals out you want. Enzymes are one of the great bits of science, great bits of evolution, which really deliver in making our lives easier. Thank you very much.